The next topic, which is related to electromagnetic radiation, is called spectroscope. Spectroscope can be it's an instrument actually which can analyze electromagnetic radiation. Okay, and then through this method, actually we are able to find out chemical compositions of any celestial objects in the sky. So this is actually a simplified version of spectroscope. Okay, so as you can see here, okay, this is a, if you have a light source here, a light source is passing through a lens, becoming all these parallel light rays, and then it's going to pass um, a barrier, and then eventually it's going to be split into different colors through this prism. And if we use another lens here to focus all the lights, so we are able to see on the screen, okay, the spectrum of the light, okay. So that's why we say that spectroscope is able to split light into different component colors, and you can see all red light, you know, they're going to focus here, or the blue light will focus here, so you can see a colorful um, visible light spectrum. And there are different kinds of uh, lines which will be formed depending on the objects here. So if we have a heated hydrogen gas, for instance, okay, it's a hot object. So then this object is going to emit light, and then passing through a prism eventually will form emission lines on the screen. So as you can see here, emission lines are colorful lines on a dark or black background here. Emission spectrum can be used to identify different elements because, for different elements on the periodic table, in fact, each element has its unique emission spectrum lines. Just like human beings, everybody has their unique fingerprint. So the emission spectrum can be seen as the fingerprint for each element. So then if we identify, okay, the emission spectrum inside a celestial object spectrum, so then we are able to identify whether this object has any particular type of elements. So like for instance, if you find um, the emission spectrum lines like this, which matches the hydrogen emission spectrum lines, then we know that this object has hydrogen atom inside, and it works the same way for the other elements. So for instance, you can see here this hydrogen atom, the sodium looks like that, and helium looks like this, and we have neon, so there are a lot of red, yellow lines here, and this is mercury. Okay, and there's another type of spectrum which is called absorption spectrum. Absorption spectrum happens to a cooler gas. So then the light actually is going to go through the same devices here, but eventually you're going to see absorption lines here on the screen. So the absorption lines actually has a colorful background, and then but with dark lines on it. Okay, so these lines actually, if you have the same element in the gas, actually these lines position would match the emission spectrum lines, but here only there are dark lines, black lines on a very colorful background here. And this shows you the absorption spectrum of the sun. Okay, so in order to summarize what we just have learned, actually what we have learned from the previous slides can be concluded by what is called Kirchhoff's laws. Okay, If you have luminous, solid, liquid, or dense gas, they're going to produce continuous spectrum. So I'm going to show you the diagram in the next slide. If you have low density hot gas, it's going to produce emission spectrum. On the other hand, if you have continuous spectrum instant on cool thin gas, then it's going to produce absorption spectrum. So, and the whole law is illustrated here, as you can see. If you have just a light bulb here, and then which is luminous, okay, object, which is going to produce continuous spectrum. So this is continuous spectrum here. If you have hot gas, and then it's going to produce emission spectrum. And then on the other hand, if you have a cold to cooler gas, it's going to produce absorption spectrum like that.